This is a continuation of the examples for the lesson on arithmetic sequences. For number 6, the task is the same as for number 5. We must write an equation for the nth term of the arithmetic sequence and graph the first 5 terms of the sequence. As we found in number 2, d for this problem is 23. So the equation for the nth term, a sub n, is a sub 1, which is negative 10, plus d, which is 23, times n minus 1, which can be simplified to 23n minus 33. Now if I draw the graph where the axes are n and a sub n, you can see the scales I've chosen. And now, before we continue, we have to find the 5th term of this sequence, which, as we did in number 2, is 59 plus 23, or 82. Now I can plot the points. When n is 1, or the first term, a sub n is negative 10. And when n is 2, it's 13. When n is 3, it's 36. When n is 4, it's 59. And when n is 5, it's 82. And if we choose to do so, we can draw the line connecting the dots. For number 7, we have the same thing as we did for number 3, and the same problem as for 5 and 6. So as in number 3, we found the difference was 1.5. The equation for the nth term, a sub n, is the first term, minus 3.2, plus the difference times n minus 1. And that can be simplified to 1.5n minus 4.7. Now let's find the 5th term, which is 1.3 plus 1.5, or 2.8. And let's draw the graph. Again, our axes are n and a sub n. Now I've chosen a scale, and I can plot the points. When n is 1, the first term is negative 3.2. When n is 2, it's negative 1.7. When n is 3, it's negative 0.2. When n is 4, it's 1.3. And when n is 5, it's 2.8. And we can draw the line if we choose to do so. For number 8, we have a bit of a word problem. Say you're playing a game with building bricks, and you want to make a triangular rise from one point to another point. You know you want to start off at a height of 2 and finish at a height of 20. And you ask yourself what you want the difference to be without being so cliche and saying it's 1. This is kind of a create-your-own problem way of doing this. So let's pick something. These bricks that you'll be using don't come in just whole sizes of 1 brick. They also come in thirds, like 1/3 or 2/3. Now you decide you want to increment by 2/3 because it'll look fashionable. The first question you ask yourself is how many columns are you going to need to pull this off? We should start by writing down what we know. So the difference, the common difference, is 2/3. The first term is 2, and the nth term, we'll say, is 20. When we use the equation for arithmetic sequences, we just have to solve this for n after we plug all of our information in. So after we've inserted what we know, we get this equation, and we have to solve for n. So let's start. You can then discover that you'll have to have 28 columns in order to do this to your liking. Now you want to know the equation to determine how many bricks you'll need for each column. This is simply just the equation for the nth term of the arithmetic sequence when you plug in certain things. Because we want it to work for any nth column, we know that n is going to be our variable. So what's surely defined is the first term and the common difference. Therefore, we can find this out and write it down. Now let's say you're working on this and you come across the ninth column, and you need to find out for the ninth column, how many bricks do you need? We just solve for when n equals 9. And you can then simplify this to be 7 1/3.